This is a follow-up question from our lab that we did with a spectrophotometry lab for limiting reactant stoichiometry. First thing we're going to do is we're going to put the copper solution into our beaker by clicking the next button. Then we're going to add the sodium hydroxide, and I'm not really showing the beaker is doing that. So now we have sodium hydroxide in here mixed with the copper solution. And we got a faint blue left over, indicating that the copper solution is going to be a little bit left over here. There's not enough hydroxide to react with it all. So now I'm going to fill a little bit of that solution into an optical curvette. It's just our little glass that we've been using, our glass test tube. And then we're going to put that into the spectrophotometer, and we're going to record the absorbance of that. So the absorbance of that blue color left over is 0.122. And we'll be able to use that 0.122 in order to determine the amount of copper solution that's left over. Okay, so now we're moving to our data sheet here. We need to record our value, okay, for the absorbance, and that was 0.122. So we'll record that right here, 0.122. To calculate the grams of the excess copper, we're going to take 0.122, and we'll divide that by 8.00, and that's going to give us 0.0153 grams, and that's really copper sulfate that's left over. Okay, and then this 8, you'll learn more when we do solution stoichiometry. So from the color left over, blue, we know that this is blue right here. So that being left over, we know that the excess reaction is going to be the copper sulfate. So we'll put that right there. Okay, now from our beginning data sheet, it does tell us the amount of copper sulfate that we're starting with, and that's 0.055 grams of copper sulfate. And it tells us sodium hydroxide is 0.020 grams of sodium hydroxide. So we now know that this one is the limiter. The solution is not clear afterwards. It's still got a little blue tinge to it. So we know that the copper sulfate is excess. So we want to find out how much of that is excess. So, but we've got our starting materials here, 0.055 and 0.02. We're going to start with the 0.02 grams of sodium hydroxide, and we're going to do a 3-step stoichiometry between sodium hydroxide and copper sulfate to figure out how many grams of copper sulfate actually reacted. So let's go do that. And again, here's our balanced equation again. So again, it's going to be a 3-step stoichiometry starting with 0.020 grams of sodium hydroxide. So I'm going to put that here. On the right side over here, I'm going to leave myself plenty of space here. I want to know how many grams of copper sulfate actually reacted. Now let's do our typical 3-step stoichiometry. I'm going to put 1 mole here. I'm going to block that spot right away. I'm going to put 1 mole here. Now the 1 mole here is for the sodium hydroxide, and this is for the copper sulfate. Okay, so, and again, set everything up with good labels. So here I'm going to put the bakery mass, the molar mass, so it's going to be 40.00 grams of sodium hydroxide. That's just the molar mass of sodium hydroxide. Over here, I'm going to put the molar mass of copper sulfate, which is 159.606. So that's grams of copper sulfate. So now I go to my balanced equation. I see there's a 1 in front of the copper sulfate and a 2 in front of sodium hydroxide. So it's going to be a 1 mole of copper sulfate or 2 moles of sodium hydroxide. So I'm going to take 0.02 divided by 40 divided by 2 times by 159.606, and we're going to get 0.039 0.9 grams of copper sulfate that's actually reacted. Okay. Now to determine the actual excess, I'll do that up here since I don't have space down there. I'll take what's given for copper sulfate, 0.0550, and I'll subtract the 0.0399, and that gives me a 0.0151 gram excess. Now comparing to that with what we measured 0.0153, we're calculating 0.0151. That's pretty close. Okay, so that's showing pretty good correlation between what we did in the lab. Of course, it's a simulated lab. We can do a better job with simulated labs. Okay, and then what we calculate. Now, our last question is determine the grams of copper hydroxide produced. Now we're going to do a stoichiometry between the sodium hydroxide and the copper hydroxide produced. Okay, see if I can move this up so we can have space to do that. Now remember, it's a 2 and 1 mole ratio there. So let's move this up so we have space. So all of this is going to stay the same. So I've got my 0.020 grams of sodium hydroxide on this side. And on this side, I want to know how many grams of copper hydroxide were produced. Notice how we're using the limiter through, because all of the limiter reacts, not all of the excess reacts, of course. Again, we're going to put our blocking 1 mole, and this again is sodium hydroxide. And we'll just go ahead and fill in the bakery mass for that. And we're going to have the 1 mole on the bottom here of copper hydroxide. Now we need the bakery mass for that. That is 97.566 grams. And that, of course, is of copper hydroxide. I'm going to try to fit that label there. Now remember, our balance equation said there's a 1 in front of the copper hydroxide. And there's a 2 in front of the sodium hydroxide. So now I'm going to take 0.02 divided by the 40 divided by 2 times 97.566. And we're going to get an answer of 0.0244 grams of copper hydroxide produced. And that is our simulated limiting reactant stoichiometry lab.